Okay, so what we're looking at here are two what are called similar triangles. Now if we just have a look at them, we might notice a number of things. So number one, the angles in both triangles are the same. So for example, this angle here, it corresponds with this angle here. Okay, so there's like a link or a correspondence between these two. Okay, they correspond with each other. They're similar angles. This angle here and this angle here are similar, and this angle here and this angle here are similar as well. Now notice that sometimes in these questions they may use this to represent an angle, they can use this to represent an angle, or they can use this here to represent an angle. But the main thing is that when you're looking at it, that you notice is that in both triangles have the same angles, which is indicated by the same symbols that are used. So again, if we look at it again, this triangle is smaller than this triangle, or the other way, the opposite or the converse of that, this triangle is bigger than this triangle. So what we can say is that both triangles are proportional to each other. Now, just a couple of things then to look at. So we have this idea of corresponding sides. So again, in similar triangles, and this is only for similar triangles, so each triangle has three sides, as we can see here. So 1, 2, 3, 1, 2, 3. Now what we can say is that in similar triangles, the sides will all of the sides will correspond with the sides in its opposite triangle. Okay, so what does that mean? It means that this side here will correspond with this side here. So it means when we say correspondence, if we think about correspondence, somebody writes a letter, people write letters back and forth to each other, or people text back and forth to each other. Okay, that means that there's a kind of link between those two people. There's some kind of a link, okay, and the common link is the text or the letter or whatever it is. So there's a correspondence, and that's analogy, if you like, is similar to what we're using here. Okay, so what we're saying is that this side here corresponds with this side here, so there's some kind of a link. And the same will be true as well. This side here will correspond or link in with this side here, and this side here will correspond with this side down here. And this is what happens with similar triangles. So what we want to try and do then is we want to try and work out mathematically, like, what is the correspondence? And in order to do that, we look at each of our triangles and we look for, let's say, a size that is present on both corresponding sides. Okay, so if we have a look here, we can't really use this one to find out what the correspondence is, because it doesn't give us the it doesn't give us the size of this line here. Okay, so we can't work out the correspondence between these two. If we look at this one here and this one here, again, there's no number value here on this side of the triangle, so therefore we can't figure out what the correspondence is between these two corresponding sides. Okay, now if we look at the bottom, we can actually work out and see that there is, so we know that in similar triangles both sides will correspond with each other, these sides will be corresponding. But now what we actually want to do is we want to work out what is the correspondence. Simply put, like without any numbers, the correspondence between these two sides is that this side is bigger than this side. Okay, so that's really simple, like a really simple correspondence. But we want to do more than that. We want to actually put a number on that, an actual quantity. And we have to try and figure out, like, you can look at it either way, okay? We can say that this side is bigger than this side, okay? Or we can look at it from the point of view, this side is smaller than this side. Now, it depends on, like, whichever correspondence we choose depends on the order. So if we want to look at how much bigger this side is to this side, then we need to look at taking 9 and dividing it by 6. So that will tell us how much bigger this side is than this side. Now if we want to look at it the opposite way around, and we want to look and say that like how much smaller this side is to this, then what we would have to look at it the opposite way around. So we would take 6 and we would divide it by 9, and that tells us how much smaller in number quantities that this size is. And that's very important. So you can work out the correspondence by looking at the difference between, let's say, the two sides. But it matters what correspondence you're looking at. So the order matters. Okay? So what we can do is we can look at it, we can try and work out like what's the correspondence between these two sides. Okay? So we can look at it from this point of view. We can say that, let's say, so this side is 9 and this side is 6. So the correspondence we can say is 9 divided by 6, and that's equal to 1.5, which is equal to just 1.5. Okay, it depends on what way you want to look at it. So one correspondence is that this side is 1.5 times bigger than this side. Okay, so that's one way you can look at it. So if we stay with this then, what we're looking at then is we're looking at how much bigger the bigger side is on the corresponding triangles. So we have a small triangle and a big triangle. So there's a kind of a rhythm to it, okay? So small, big. So we have, this is 6. So therefore, the correspondence between the sides we've worked out is 1.5, okay? So that means that this side here is 1.5 times bigger than this side here. And that correspondence will hold true for all of the corresponding sides, okay? So for example, this side here is going to be 1.5 times bigger than this side. This side here is going to be 1.5 times bigger than this side, because they correspond to each other and because they're similar triangles. So if we take these particular triangles, if we look at them, what we want to do is we want to look at, first of all, work out the correspondence. Okay, so work out the correspondence. So you're trying to figure out, look at, have we got a number value on two corresponding sides, and that will allow you to work out the correspondence. The next thing then that you want to do is, once you've worked out the correspondence, in this question it asks you, it says, these are similar triangles, find the length of the side DE. Okay, so the side DE, okay, so that's this side here. So this side here. Now, its corresponding side is this side here on the small triangle. We know that these are corresponding, so these are corresponding sides. Now, what we want to do is we want to work out, well, what is DE? So DE, we want to work out what's the actual length of DE. So we can use this correspondence that we've worked out. So we know that the bigger side of the triangle, the length of it, it's going to be 1.5 times the length of its corresponding side on the smaller triangle. So we take our smaller triangle, which in this case is 4. So DE is going to be equal to 4 multiplied by the correspondence, which is 1.5, which works out as 6. So what that means is that this corresponding side is 6. Okay, its length is 6. So if this one's 4, okay, the small one is 4, the small triangle side is 4, its corresponding side is going to be 1.5 times bigger. So it's going to be 4 multiplied by 1.5, which brings it up to 6. Okay, so that's the side for that. And then what we want to do is we want to work out what's the size of DF. Okay, so DF, so the size of DF. So DF is this side here. So again, what we want to do is, remember, this is our small triangle, and then on the bigger triangle, this is the corresponding side to it. So there's a correspondence or a link between these two. Okay, we know it's the corresponding sides because we can see, we have the same angles. It's the same side, except this is just a bigger version of the smaller triangle. They correspond. So again, what we want to do is we take this value here, which is 5. So that's the size of that side on the small triangle, and we multiply it by the correspondence, which is 1.5. We multiply it by 1.5, and that's going to be equal to 7.5, which is equal to 7.5. So what we do then is we just multiply it. We multiply this by 1.5, and that will give us the side of its corresponding side on the bigger triangle, which is 7.5. And that's your answer essentially. Okay, so again, just to recap, so similar triangles, they're similar because they have the same angles as each other. Okay, and as a result, there's going to be a correspondence between each of the sides. Okay, this side will correspond with this side will correspond with this side will correspond with this side. Correspondence just means like there's a link. Okay, and what we can do to work out what the correspondence is, we look for a side on both triangles that it gives us the dimension. Okay, so in this case it's 6, in this case it's 9. So we can work out from this by using division. Okay, so 6 divided by 9, it tells us then that the correspondence between these triangles is that the smaller side, the larger side here is 1.5 times bigger than its corresponding side on the smaller triangle. So that means that, so for example, this side of the small triangle is 6, so therefore the size of the larger side on the triangle is going to be 1.5 times that, which is 9. Okay, so that's the correspondence, and that's going to hold true for all of the sides, all the corresponding sides. This side corresponds with this side, so therefore if this is 4, then this has to be 1.5 times bigger, so it's going to be 6. Okay, so we worked it out by multiplying it, and the same here. Okay, so if this is 5, then this side is its corresponding side, so it has to be 1.5 times bigger. So we multiply this by 1.5, and it's 7.5. So that's what we mean by similar triangles, and when we're looking at this idea of corresponding sides. Okay, hopefully that helps. Thank you.